Evening, absurdity fans, science lovers, and truth seekers, of course. So what do we have here? Well, here we have 5mm bulb, right? It's just gone out. And we have that cross is where Earth is, but at 45 micrometers, so it's so small we would not see it compared to that 5mm bulb. I'm going to go into that just after this. That moon is there for tomorrow. The science says it takes the sun, has a diameter of 1,390,000 kilometers, 8 minutes and 20 seconds to radiate its light, the 150 million kilometers the distance between Earth and the sun. Earth, sun. It's been brought down to scale with a 5mm bulb. If the sun were a 5mm bulb, the distance to Earth would be 54 centimeters, and Earth would be a speck, not even. This is what they say. This is what does happen. You can see that's radiate. It's like to us, we're on Jupiter's orbit line, right? Earth, it zoomed past it like you can't believe, right? But according to the science, this is what would happen when that bulb switches on. See that outer ring? Call that the light, right? The outer ring. That's the light that's going towards Earth. So this goes on and this happens. So I have to stand here for 8 minutes and 20 seconds. Remember the outer ring, not the inner one, the outer ring. Be by Mercury now. Outer ring. So I'm going fast. What have I been going for? 30 seconds maybe? So you've got to picture this. Something with a diameter. Right, it's coming up to Earth. Boom. 8 minutes and 20 seconds for the sun to radiate its light to planet Earth, 150 million kilometers. 4.6 seconds it takes for that 5mm bulb, if it were the sun, to radiate its light one diameter of itself, 4.6 seconds. This is where the problems start. And this is why we're doing it again, but in a little bit more detail. Right, I said that the measurements of Earth didn't really matter, but for what we're going to do, it does. So I'm going to go into it very briefly in layman's terms, right? I'm going to try to make this as easy as possible to understand, right? I'd just like to thank those of you that have started to share some of my content. It means a lot to me because, yeah, the brakes are getting put on it. So if you think I've got something to say, these numbers are bang on the money, right? We're gonna find out how big Earth is because tomorrow when I do the second part, Earth, we need it so we can keep things into perspective. How do we know Earth is 45 micrometers and what is a micrometer when the sun is a 5mm bulb? Oh God, it's cold. Sun's diameter. We divide the sun's diameter by the Earth's diameter. We get 109. Alexa, what is 1,390,000 divided by 12,742?
1,390,000 divided by 12,700 is approximately 109.4488.
Still 109, but she did say 12,740. I clearly said 42. I know I said 42. 109 Earth diameters in the sun, right? easy to mistake the 108 sun diameters that are between Earth and the sun, right? So 109 planet Earths in the sun, right? We know that because the sun has a diameter of 1,390,000 and we've divided it by Earth's diameter. So now we divide the 5mm bulb that we're using for the sun by 109, and that will give us how big the 109 Earths are, right? So 5mm bulb divided by 109 Earths. Alexa, what's 5mm divided by 109?
5 millimeters divided by 109 is approximately 0.0459 millimeters.
That is, she said 0.045 millimeters. So that's basically 45 thousandths of a micrometer, right? Let's go and see what a micrometer is. We have 10 millimeters in 1 centimeter. There are 1,000 micrometers in 1 millimeter. So in the 10, there are 10,000 micrometers, right? 1,000 in each millimeter. I have blown 1 millimeter up, magnified it, and I've broken it down into 5 sections, 200 micrometers in each section. That's 1 millimeter. Each 200 section, we've got 50, I've broken it down to 50, 50, 50, and 50. Earth is 45 of one of those 50s with 5 left over. So basically, Earth will go into this 4 times and have 20 left over. 4, 8, 12, 16, 20, and that should be 100 left over. Yeah, it is. 20, 40, 60, 80, 100 micrometers left over. Earth is 45, so we should get 22. 22 planet Earths in 1 millimeter with a few micrometers left over if the sun has a diameter of 5 millimeters, right? That's what this is about, because when I come back tomorrow, when we come back tomorrow, we are going to take a look at why it is that a bulb 5 millimeters absolutely smashes the world record compared to the sun, right? Because this here sun, this is 1 meter in diameter. According to the science, pound for pound, if this were the sun, and this would be 1,390,000 kilometers, that distance, because that is the diameter, and it would take this sun, if it were a full-size 1,390,000, 4.6 seconds to radiate its light to here. Now, can you see where the problem is? A 1 meter in diameter sun will take 4 seconds. Right? To radiate its light the distance of its own diameter. A bulb doesn't, right? Floodlights at one of the games doesn't. If they put those floodlights on, you'd see it at kilometers away, right? There are, Alexa, 200,000. Alexa, how many 5 millimeters are there in 1 kilometer?
1 kilometer divided by 5 millimeters is 200,000.
Right. Now, if somebody was 1 kilometer away, right, I turn that bulb on. How long? I turn that light on, the light goes on, the person sees it, you'd think immediately, right? That's 200,000 diameters in the sun, one diameter, 4.6 seconds. Baby bulb, 200,000 diameters of itself, not even a problem, for crying out loud. But the sun, 4.6 seconds for one diameter. There's a few other little bits and pieces. So tomorrow, we are going to have a look at the sun and how big planet Earth would be and the distance from the size of a 5mm bulb all the way up to 1,390,000 kilometer a diameter star. Don't do this to me now, phone, I'm about to knock off. So folks, you must be able to see what I'm saying, right? No, the sun's light is absolute, for sure. 4.6 seconds to radiate its light the distance of its own diameter. More tea, Vicar. All right, folks. Part 2 tomorrow. Layman's terms. See what you reckon. Thanks for sharing, guys. Laters.